Okay, geometric sums is the last one in this sequence, no pun intended, about sequences and sums in series. And so this is the last new lesson before we have a test. I'm going to start with the definition, and that is the sum of the geometric sequence a sub 1 times a1r times a1r squared, on and on and on, till I get to a1 times r to the n minus 1. That follows from what we did yesterday. That sequence with common ratio r which is not equal to 1, so the difference is more than 1, is given by the sum of the sequence is the sum from I equals 1 to n of a sub 1 times r to the I minus 1, which is the same thing as saying a sub 1 times 1 minus r to the n over 1 minus r. This is the part of the formula that you're really going to need to use. This is just the big fancy definition. So we're going to find r, the common difference, in the term of the sequence, a, the first one, and then that will be the sum of any given one. Example 1. I want the sum from I equals 1 to 12 of 4 times 0.3 I minus 1. Now this was given in this form, right? And I want this answer. So a1, the thing that took place at a1, is 4. 1 minus the r is 0.3, right? The n is 12 over 1 minus 0.3. Now, it might help you to go ahead and write some of this stuff out. So let's find a1 took the place of 4. R was taken by 0.3, and n is 12 because that's my upper limit, excuse me. If I plug all of this into my calculator exactly like it looks, put this top in parentheses again, I'm going to get 5.714. And that is my sum of the first 12 terms in this geometric sequence. Okay, the sum of an infinite. So what do I do if it's infinite? Geometric series where the absolute value of r is less than 1. I have a1 plus a1r, plus a1r squared, on and on till a1r to the n minus 1. That a1 never changes, obviously, because it's the first term in the sequence. That's how we defined it. Has the sum, the big sum, because it's from 0 to infinity. Notice it's 0 and not 1. Of a sub 1 ri to the I is a1 over 1 minus r. When would that apply? So let me show you an example like that. Example number 2, I want to find the sum of the sequence from n equals 1 to infinity of 4 times 0.6 or 0.6 to the n minus 1. I want to find the infinite sequence there. To do that, I want my a1, which was 4, that's this piece right here, my r, which is 0.6, and I want the infinite term, so I'm going to use this formula. So s equals 4 over 1 minus 0.6, and that would be 4 over 0.4, which is equal to 10. So the sum of the infinite sequence is 10, and that's actually pretty easy. You're just using those formulas. Your assignment number 6 is page 669. It's numbers 53 to 56 and 79 to 80. Good luck, and let me know if you have questions.